in real world?
Hopefully, can you hear me? I mic'd myself up for the first time, so, all right. So I'm going to talk about unikernels in the real world. How many of you guys here are familiar with unikernels? Cool. How many of you have played with them yourself? How many of you have put them in production? Oh, okay. Well, that's pretty good. So actually, this is about, it's originally kind of titled Baby Steps to Production, unikernels in production. But I thought actually maybe it made more sense to highlight that we actually want to solve real-world problems with unikernels. So a little bit about me. I'm a VP Eng at a company called PayGarden. We allow people to take gift cards as a form of payment. So you drop in our SDK. Someone can use a Target, Best Buy, whatever gift card to pay for your service. So it's kind of a very, very typical Silicon Valley-esque niche that we live in and that we want to apply unikernels to. So I've been in startups for about 8 years, so that's where I'm coming from. Our team does a lot of work integrating with external APIs. Because we're a payment system, reliability, accounting systems are very important, operational metrics, that kind of thing. We're primarily a JVM enclosure shop, and so OCaml and actually ML languages in general are a very new thing for us. It's a little bit of water and oil in there, but it's actually been quite interesting. But whenever we were first looking at unikernels, we kind of have a set of criteria that we're judging them by, right? Wondering whether or not they're worth the cost of introducing them. So a big one is social buy-in. So again, like I said, closure list people tend to be almost diametrically opposed in many of their ways of thinking to ML people. The cost of onboarding people, the changes in dev flows, how much are we going to upset our productivity that we have already? Are we able to deploy this stuff, right? Undeployed technology is absolutely useless to us. We get no benefit out of it. Things like monitoring, testing, very, very basic stuff that we actually have to rethink with unikernels. So a real quick caveat on this talk, actually quite a few. This talk actually reflects personal experience. It may be very, very different from yours. What works for us may not work for you. Quite a bit of it is subjective, and it's very Mirage specific. Cool. So it seems like most people actually know what a unikernel is. Just real quick, I'll give the idea that we're going to throw out, for a unikernel, we're going to throw out the existing operating system. We're not going to use the Unix kernel or anything like that. We're actually going to make our app become the entire VM. So we have a very highly specialized VM that contains only our application and no other code. And we don't pay for anything that we don't use. And this is the obligatory unikernel slide that you're supposed to show in every talk. So with the traditional stack, we have configuration files, our application binary. Our application is going to be running on probably some runtime. That runtime is one of many processes that's actually running on a machine that's managed all by some sort of kernel underneath it. Probably have a file system and a network stack. And with the unikernel stack, we're actually going to collapse all of that down to compile time. So we're going to produce an immutable artifact that is going to power everything for us. So as far as the industry, there's a good question to ask is why would the industry actually want the characteristics of a unikernel? And there are a few things that kind of stand out. Resource usage is a huge one. The fact that we can make much, much better use of the servers that we have is a huge plus point. Security, because of the reduced attack surface area, security is potentially quite improved with unikernels. Because of the changes in the way unikernels work. So unikernels are very, very tiny, and they can boot extremely quickly, which means that the kinds of infrastructure that we can build are quite novel. And it also means that things like we can build new kinds of dev tooling. Because of the extremely immutable nature, in our case, for example, whenever there is an error in production, we're actually able to take that exact server state, serialize it, and boot up the same exact VM in development and debug it locally. So we have immediate repro cases of any error that happens. And then the last one is simplicity. There is no way a single human being can hold all of the Linux kernel in their head at this point. Whereas with Mirage, it's actually just on the edge of possible, probably. So if we look at kind of the history of deployment in the industry for the past 20 years, kind of starts off with, we had bare metal servers that were installing our operating system and our applications on. Every server is bespoke. It's a snowflake. It's unique. It's special. We started moving into virtual machines to make better usage of the hardware. And this kind of naturally led towards a much more immutable infrastructure, where because we have kind of serializable artifacts, we can start to change the way that we do deployment. And so this led to things like continuous deployment, where we can actually deploy our new version. If something goes bad, we can go ahead and revert to the old version because it's all immutable. And you can see that as we kind of have moved through the years, we're heading towards very repeatable, very reliable, and very scalable infrastructure. That seems to be the kind of the common theme here. And so if you wonder, like, what's next, like, I'm kind of curious, it might be something along the lines of Mirage, because Mirage kind of takes the immutability to even the next level. So as far as unikernels for us, we actually really care about the simplicity aspect. We're a tiny, tiny team. And so the ability to actually understand the entire stack whenever something does go wrong, to build those kinds of advanced dev tooling is really important for us. We get a huge amount of leverage out of it. So the example unikernel talking about is, your bread and butter application you might see in the industry. So something along the lines of, we're going to boot up a server. It has an HTTP endpoint that presents some API that a mobile client or a browser client can hit. And it's going to go off and scrape the web for us, do some work, and return some results. So unikernel, or Mirage in particular, is pretty cool because we can actually develop it first as a Unix application. The way that they have structured this means that we don't actually have to jump head first into the unikernel aspect of it. We actually compile everything as a typical normal Unix application, and we get kind of a taste of, is this going to work for us? So we get to market much, much more quickly, and then we can kind of slowly work our way into the unikernel infrastructure. So there are some challenges here, though. In particular, whenever we actually compile for a unikernel backend, we no longer have Unix at our disposal, right? And so it's very easy to introduce some dependency that transitively depends on Unix for something. Even something as simple as a time library might depend on unix.time or unix.sleep or something along those lines. And so it can be very easy to unwittingly add that in. You just reach for a library that's already written. You install that. You build your application around it. And it comes time to now deploy to a unikernel. And you find out that it's not compatible. And you have to painfully rip that out and rebuild your application to be compatible with the restrictions of a unikernel. But it's still, like I said, it's a great first approximation. It means that we can get to market quickly. We can prove the idea. And we can improve iteratively from there. But then when it comes time to move from the Unix to the unikernel transition, we kind of have like 3 phases. There's like the prototyping phase, the production phase, and hopefully at some point the next gen phase. So prototype, I think, is where we are right now. Most of the unikernel deployments are very, very prototype. We're right on the cusp of production, though, and hopefully I'll talk a little bit about where we can go with the next gen stuff. So by prototype, as far as unikernel deployments, what I mean is it's a very, very artisanal process. Every single build, you are highly aware of the dependencies that go into it, the command line flags. You're creating these artifacts. You're copying them over to another server. The infrastructure that you're running them on is also bespoke, right? Even though the VM itself is immutable, you have to know a lot about the Xen hypervisor. You are setting up a server that you are going to have to maintain for quite a while. It's very, very difficult to deploy these things. You have to learn a lot of kind of incidental complexity about all of the underlying hypervisor layers. Once you do get it running, there's basically low to no monitoring. So there are some unikernel sites that basically go down 4 days and nobody notices. No one gets an email. And when it comes time to scale out, there's very little infrastructure or tooling out there to automatically do this. It is all on you. So kind of the theme here is that we can do it, and it is an interesting process, but it's very, very laborious. Once it is running, it's very, very wobbly, and it's not the kind of thing that you want to have running if you're on pager duty. But I think we're actually right on the cusp of a production phase where we can actually entirely automate the builds, we can automate deployments, and we can actually reuse existing public infrastructure, which for us as a small team is incredibly important. We don't want to be running a Xen hypervisor system. Right? We don't actually want to know about that. We just want to take advantage of the benefits. So things like public hosting, monitoring, using scaling, whatnot. If we can find a way to use the existing infrastructure, that's a huge win for us, so we don't have to build it ourselves. And assuming we have this in place, like it's enough supporting infrastructure to actually start pushing this to production. But there are definitely a huge number of challenges to overcome in the Mirage world, particularly, to get started with. Right out of the gate is dependency management. This has been a huge thorn in our side. It's a very basic idea, but it is foundational to being able to actually build these things reliably and put them into production. OPAM doesn't seem to be terribly declarative. And again, we're coming from the Clojure or Node or whatever world. And so we may not understand all of it super well. This is just our experience. But one really big problem that we have is the seemingly non-deterministic install or dependency resolution. If I get something working on my machine and I check that in and a coworker checks it out and tries to set up all the dependencies, there is a much higher chance that they will get a different set of dependencies on their machine and likewise on the build machine than I had. And so this has actually been quite a big challenge. And in particular, it's exacerbated by the fact that Mirage is a very, very fast-moving project in many ways. And so that means that we have to pin remote repos. We have to pin to specific package versions. And it's very, very easy for us to forget something, ended up with an incompatible build. And so we've lost days and days and days to this. To give you an example of what we're used to, in the Clojure world, we can simply declaratively say the exact versions of all the dependencies we want, and it just kind of works. Same from the Node world, and with OPAM, it's a little bit, I'm not entirely sure, it seems to be something along the lines of you simply just tell the names of the dependencies, and you cross your fingers that it installs something appropriate. So we actually consider this to be an unsolved challenge as of yet. And then directly stemming from that is the different environments that you're actually building for, the targets. So in theory, Mirage actually can compile for Unix, for ARM64, it can compile for a Zen hypervisor, and now for the KVM hypervisor. In reality, it is quite laborious to switch between these things. In particular because each of them requires different dependencies, and installing one will affect the other. And so we haven't entirely solved this either. Some of the suggestions have been to use Docker for each of the different approaches, or for each of the different backends. But Docker is, every time you introduce a new tool into your developer workflow, you have to figure out if it's going to pay for itself, and it's unclear whether or not Docker is going to at this point. So if you guys, for shops that eat, sleep, and breathe Docker, that's probably not really a big deal. Production hosting is another really big one. So like I said, undeployed technology is useless to us. We initially tried EC2, but the primitives that they expose are actually a pretty bad match for the Mirage unikernel. It is very, very difficult. It's a 12-step process. Every single deploy was about 30 minutes of manual work. Once we actually got it deployed, we weren't able to take advantage of any of the scaling, the load balancing anyway. So it was cool, to see it working, but it was definitely not something that we could invest in as a small team. More recently, because of the Solo 5 project that has landed, Mirage is now able to target the KVM hypervisor. And this allowed us to actually try out Google Compute Engine, and this has been fantastic. This has worked out really, really well for us. The primitive seems to match very closely. So we can have a build machine that produces a Solo 5 artifact. It uploads to the Google Cloud Storage, creates an image, and boots it within minutes. So on every single Git push, we can get a running image within minutes. It's fantastic. And not only that, but if we are on master, for example, it will trigger a rolling update with 0 downtime. So we are actually able to take advantage of the existing infrastructure seamlessly. It's fantastic. So I feel very, very comfortable with the production aspect, or production hosting aspect of Mirage right now. Logging is another super important one, and this seems to match very well also. So we use the Google console just for any ephemeral logs whenever we're doing, print inline debugging. And for anything we use external services for persistent and searchable logs, and it works just fine. So this has also solved problems as far as we're concerned. For the Mirage workflow to kind of come together, you really need to have a continuous integration and a continuous deployment pipeline. And right now, the way we do it is we have Circle CI actually build for the Unix target. We run all of the tests. If that's successful, we create a Solo 5 artifact that gets uploaded to Google Cloud Storage, and an instances or image is created. And if we're on master, like I said, it'll trigger an update automatically. So this part has been fantastic, where if we can, assuming we have the dependency management part solved on that build machine, it's a bit finicky to get set up, but once it is, everything else goes entirely smooth. It is very, very nice. So that's solved as far as we're concerned. Not only that, but because we use the public infrastructure, it means we get things like scaling based off of CPU usage entirely for free. So the way we set it right now is that if the CPU is above 60% for in seconds, we boot another instance. And if it drops below 5%, then we just kill the old ones. And on top of that, we get health checks every 30 seconds. So the KVM backend is still very, very new. And whenever I deployed my personal sites with it, it would serve about, I think, 50 requests, and then it would die. And I mean, it's a personal site, it's not really a big deal. And the way I got around that was not to actually dig in and figure out what the problem was. I just turned on the health checks, and Google would see that and just boot up another image, and I didn't care. But it's actually incredibly nice for us. It is much better in the middle of the night that Google just boots up another one and throws away the old one than waking me up and asking me what to do. So it's very nice. So that part is fantastic as well. So where we are right now is pretty good. We're pretty close to actually on the cusp of being able to productionize unikernels and feel very comfortable with it. But in many ways, we are limited by the current infrastructure. So the next generation will be something much more unikernel aware. So for example, unikernels boot incredibly quickly. Like our service boots in under 100 milliseconds. But if it takes tens of seconds to get an instance, which is pretty fast, truth be told, but for a unikernel, that means that the 100 millisecond boot time doesn't really make so much of a difference. So we really want to find, in the future, some sort of much more unikernel-aware infrastructure. This would allow for kind of, I think, Anil and friends have called like the dust cloud, this idea where every single TCP connection that comes in, we would boot up an instance just for that. As soon as the connection is finished, we kill the instance. That would be fantastic for us. I really like this idea. But there is a problem. So Google's model is pretty cool. It's per minute right now versus AWS's per hour. But that does mean, imagine that we were running a website as a unikernel. And so one request would come in, we'd boot up a VM, we'd serve you the HTML, it'd list maybe 100 different images inside of there. 100 different requests get spawned, so we boot up another 100 images, and we kill them all. And we just pay for a minute for every single one of those. And really, we actually want kind of per second or maybe even per 100 millisecond billing model for unikernels. And then also things like, because of the super immutable nature of unikernels, something that was aware of it would be able to roll back to previous working versions much, much more easily. So as it stands, we're able to take advantage of existing infrastructure, and that gets us to markets with unikernels, and we get to experience some of the advantages, but we're kind of inherently limited by the nature of the existing infrastructure in some ways. So we have a few kind of ongoing concerns with regards to the industry being able to adopt Mirage unikernels in production. A perennial one for every dev community is documentation, but it is particularly bad in OCaml. And I say this as having tried to bring a team up to speed on OCaml using various packages and whatnot, and having a very, very hard time. So actually the tooling is, or the problem is not so much with the language as much as with the various packages. More often than not, you just see kind of a dump of types. And again, coming from the Clojure world, this is a very, very difficult and different way of thinking for us. And so it has been very slow to actually get the developers up to speed with a lot of this stuff. The community is also in kind of a different world in many ways. So it's like a mailing list and IRC-based approach. and I think a lot of new devs are used to Stack Overflow and Slack. The ability to easily ask and answer and search questions is there, and it's not necessarily taken care of very well, I think, by mailing lists and IRC as it stands right now. And then finally, it's unclear at times what the goals of Mirage is, whether it's meant to be a research project or actually an industry tool. And I think you've seen a lot of progress where it has been used in industry, quite a bit, so in particular in Docker. But it's unclear where support for kind of industry use is actually put, right? There are a few people in, the team is incredibly small, and they're doing crazy amounts of work, and it's, they get pulled in all sorts of different directions. So it's understandable, but still, it's a concern. So as far as kind of going back to the real-world concerns that we have, the few that kind of stand out are the onboarding and the effect to the dev flow as it stands right now with the concerns. Everything else is actually quite well taken care of. We can get to market quickly with these things. We can debug as well, if not better, than our normal services. We can scale. Testing is all there. It's actually done. It's quite nice. And a lot of the potential that we get from OCaml has been quite nice as we start to build out on it. So the last kind of thought I have is the concern around the chasm. And it's unclear whether Mirage is going to be able to gain enough momentum to get on the other side. So this is like a crazy talented group of hackers that have been working nonstop for years to basically rebuild the world in OCaml from the lowest layers up. And so like for years and years, they've been doing this and kind of on the innovator side. And it's just reaching the point where early adopters can start using this and pushing it into production and actually building businesses off of it. But because some of the community concerns, because some of the concerns around onboarding, documentation, community, culture, mismatch, and whatnot, it's unclear whether or not it'll actually develop enough momentum to jump over into the early majority. And a lot of, basically this gap right here is this is where cool tech goes to die. And I would hate to see that, because what happens is, for us, it would mean that the community never grows to sufficient size, and so we don't get a lot of the benefit that, say, the Java ecosystem gets or the Node ecosystem gets. So I'm definitely rooting that Mirage can get to the other side, but we just have these concerns. So that's it. Happy to take questions. All right, I answered every question. I actually feel good about that.
Matthias here. How does HalVM compare? Do you have any knowledge about that one?
No, so actually, I am only aware of the idea, and I've seen some of the talks from it. But I think they have done a number of pretty impressive production deploys, but for quite a different part of the industry, right? So this is not like web dev kind of stuff. I think they're very heavily focused on kind of security and that kind of stuff.
Thanks.
Mm-hmm. Hi, I had a question. I had a question about the scaling. You mentioned that you weren't able to get scaling with AWS, but you were with Google. Was there something in Zen by interfacing it with directly that was causing auto-scaling groups not to work?
No. It was simply like the amount of effort to get a AMI that we could then plug into. So we're used to, for example, using Elastic Beanstalk with the JVM and Tomcat and whatnot, and that was just basically super smooth, right? Like we push this artifact and it just works. Creating manually a bespoke AMI and then plugging that in the right place, not being AWS experts, we basically got lost time and time again.
Cool, thanks.
Okay, let's thank.
Hi, do you have any performance benchmarks of running Mirage compared into a binary on a single core machine versus running on Google Compute Engine, the same sort of thing as a unikernel? You
mean so comparing, for example, a Unix target and a KVM target?
Let's say you build your website and then run a benchmark running that website on a single core VM versus running that on a unikernel, on Linux versus unikernel.
Yeah, so I don't have anything in particular right now, and I actually would be surprised if the performance was great on KVM right now, because the Solo5 project is so new. They've written the virt.io drivers from scratch, and so I think performance will come a little bit later. And I would expect the Zen backend and the Unix backend to be significantly more tuned right now.
It's just I saw the other day slides from IncludeOS unikernel, and the interesting slide was that they said 5 to 20% higher performance on the unikernel versus single core VM. But other than that, I haven't seen other unikernel systems to have any benchmarks.
Yeah, so a lot of the numbers that are pushed for Mirage are around boot times, for example, because they are so small, they can boot in tens of milliseconds. The performance is still likely to be similar, like within a factor of 2 probably, or a factor of 1, I think, with a normal Unix backend or something. Yeah.
Last question.
I'm one of the core developers of Mirage, and I just wanted to thank you for the talk, because it's very rare that we get the full perspective of a full deployment, and just seeing the good and the bad is just very motivational for us as hackers working in the project. So I've created about 10 bugs from your talk, and we'll hopefully get some of them on the flight home.
Awesome.
So just want to say thank you.
No, I mean, you guys do all of the work, so it's great to just be able to use it. So thank you very much.
Okay, let's thank Tom.